So here we have chi-square test for independence, and is used to determine whether there is an association between row and column variables. And first, we have to know what is null and alternative. So I'm writing what this one is. Here it says that null hypothesis is that the variables are not associated, or in other words, are independent. And here alternative is our variables are dependent or are not independent. So it doesn't matter which one you write. I'm writing these two here. So null is the variables are independent. And alternative variables are dependent, or we can write not independent. Now on this part, what is given here, we have this table. We're going to have this one again on the second page. Example number 1. What we have here for sample size, the sample size for male is 883. So this is total what we have for males, and the total for female is 893. And they were asked if you could have only one of the following, which would you pick? So we have 3 columns, and those are money, health, and love. And these are the responses. If in case you didn't have these two numbers given, we can find these by adding what we have on the first row. 82 plus 446 plus 355, that is equal to 883. This is total for male. And here adding these 3 numbers, this sum is equal to 893. This is exactly what we have here. Now on this part, here is chi-square distribution. Number 1, it is not symmetric. As you can see, we based on what we have here, these are not symmetric. But if we try to increase our degree of freedom, so from degree of freedom equal to 2, if we increase that one to 30, this one is more symmetric. So it's more symmetric when we're trying to increase our degree of freedom. So the shape of distribution depends on degree of freedom. And number 4, the values of chi-square are non-negative. As you can see here on left side, I have nothing. The only part that we have is on right side, we have positive. So we don't have any negative number for chi-square. The idea behind testing this types of hypotheses to compare, so we're trying to compare actual clients and counts that we would expect. So comparing these two, With actual cons are, these are observed. We had this before. These are observed values, and cons we would expect, these are expected. We're going to use O for observed and E for expected. So comparing these two, if a significant difference between the actual cons between observed and expected, if we had any difference between these two, we take this and as evidence against null. So this way we can decide if what is our conclusion after comparing these two, observed and expected. On TI 8384, we're not going to find a difference between these two. Actually, we're going to use TI 8384 to find chi-square, and that's really easy to find the answer. But if we try to find the answer by hand, we have to find a difference between these two on top and numerator first, square it, and divide by expected value again. So it depends on how many variables we have. We have to do the same thing for all of those and then add them to find chi-square. On test, I will not ask you to do that way. Now here, example, determine the expected cons in a test for independence. Here again, we have these numbers that we had on the first page. So total males, we have 883 and female is 893. Our question is, determine the expected con within each cell, assuming that gender and response are independent. So this is our assumption. Gender and response are independent. So that is our null. Again, I'm writing these as adding what we have on the first row for men. Here we have, this is equal to 883, and for female, adding these three numbers, that is equal to 893. Now, starting with step one, we first compute row and columns total. I already have the answer for these, 883, and here is 893. Adding the first row and second row, do same thing for first, second, and third column. Add these. For the first column, I have 128. That is 82 plus 46 is 128. This one 1020, and here the third one is 628. And finally, this part is table total, or that is our sample size. We already know what our sample size is, half, based on what is given on top. And that's fine. Our sample size is equal to 883 plus 893. So that is 1,776. This is our sample size. So do the same thing on this part, adding either these two or these three. It doesn't matter which one. You're going to have exactly the same answer. And that is equal to 1,776. Now step 2, compute relative frequency. We already know how to find relative frequency using these observed values. Divide by what total is to find relative frequency. So here we already added these numbers of finding sum of frequencies, and for these we got 883. So that is only for first row. We didn't add all of them, so it's 883 divided by what is total. This one is 1776. I'm going to run to 4 decimal places. So this one is 0.4972. Now for Vmin, sum was 893 divided by total was 1776. Rounding is 0.5028. Do same thing for all these 3 columns. We added 82 plus 46 is 128 divided by total. So this one is, okay, I'm writing up for here, 0.0721. Here is 1020 divided by total. This is 0.5743. Now, finally, this one is 628 divided by total. And answer is 0.3536. And here, this one is obviously equal to 1. Why? Because here we had 1776 divided by itself is equal to 1. Now step 3, assuming gender and response are independent. So this was given already. So that is our null. We assume that one. We use the multiplication rule for independent events to compute the proportion of observations we would expect in each cell. So here we're going to use multiplication rule. For example, so this is what I have in general. Probability of gender and response, that is equal to probability of gender multiplied by probability of response. So this is what I'm going to use for all of these. For example, I'm going to write this one. This is the first row, third column. So we have men, love. We're trying to find probability of men and love. So that is probability of men multiplied by probability of love. Probability of men is, we already have that part here on top. As if you remember, I already told you that this relative frequency, that is same as probability. So this is same as probability. And here we're trying to multiply these two probabilities. So probability of men is 883 divided by 1776 multiplied by probability of Love is this one. Is 628 divided by total. I multiplied and I rounded to 4 decimal places. My answer was 0.1758. So this is the answer for this one. Okay, so I'm going to continue on this part. This one now is Veman log. So for Veman, we have 893 divided by total. This is probability of Veman multiplied by probability of love is 628. And my answer is 0.1778. Here is Veman money. So Veman is 893 divided by denominator multiplied by. For money, we have this one, 128 divided by total. So this is 0.0362. Do thank you for all of these, and I have 0.2888. Here is 0.2855, and here is 0.0358. Okay, I'm going to work on one of these. So this one is Veman Health. Veman is 893 divided by denominator multiplied by. For health, we have is this one is 1020 over 1776. Now step 4, we multiply the expected proportions from step 3. So whatever we had here on top, step number 3, we have to multiply those numbers by our sample size. Our sample size is 1776 to find the expected count. So what was given on top here was these numbers are observed values, and after multiplying by sample size, we are able to find expected frequencies or expected counts. So these are same. So the first one for man and money, we had 0.0358. We multiply that one by, so we multiply by 1776, and I'm going to run to 2 decimal place. So this is 63.58. This one is 64.29. Here is 507.05. Here is 512.91. For men and law, here is 312.22. And finally, this one is 315.77. So these numbers These are expected. And I'm going to write the numbers that we already have here on top. These are observed. I'm going to write these here on this part so we can better see and compare all these. Here for the first one we have 82. This is observed. Here is 46. This one was 446. 574. Again, these were given. 355. And this one 273. So these are observed. And now here it says, consider expected count for women and love. The expected count was obtained by multiplying the proportion of individuals who are women and the proportion of individuals who chose love and the number of individuals in the sample. So I'm writing what we have here, the expected count. Expected count or expected frequency. This is for women and love. What we did was that we multiplied proportion of women, or we can say relative frequency. So this one relative frequency, multiply that one by proportion of love. So here again, this one is relative frequency. So proportion or relative frequency, these are same. Finally, we multiply by, in step 4, we multiply by sample size. So we did all these to find expected count. So here we had 893 divided by total. Proportion of love is 628 divided by total. And finally multiply sample size. Here we can clear this fraction. So divide this one by this one. Here is 1, 1. So what's left? Multiplying what we have on top numerator is 893 multiplied by 628 divided by denominator we have 1776 multiplied by 1. This is what we have, and my answer here is 315.77, which is exactly same as what we got here, this one. So this is women love, so same answer. So instead of finding proportion of women, multiply that one by proportion of love, and at the end multiply by sample size. Instead, we can use this formula. So we don't need to find the relative frequency. After finding what total is for row and column, multiply those two numbers and divide by total. See, that means I don't need this step. I don't need step 2. I only need step 1. So after finding sum, here for women we had 893, and for love we have 628. Multiply these two numbers and then divide by what is table total. That's it. So we don't need step number 2. We don't need step number 3. And we don't need this step number 4. We only need step 1 and multiply and divide here. So this is expected count or expected frequency. So if we try to find the answer by hand instead of Statcrunch or TI-8384, this is the formula that we need to use. So that's it for the test of independence. So observe here is O, here we have I, and that is starting from 1, 2, 3, depends on how many we have. I'm going to use N. And here E, I is starting from 1, 2, 3 dots, and here is N, because I don't know how many we have. So here is formula to find chi-square, and how we can find degree of freedom, because we said the shape of this distribution depends on what our degree of freedom is, and how we can find that is row -1 multiplied by column -1, that is degree of freedom. So this R is row, and this one is, okay, it's number of rows and number of columns, how many rows and how many columns we have. And yeah, I'm going to write this one, the chi-square. So to find this chi-square, here this one is sum. So we have to add, starting with the first one, observed for the first one minus expected for the first one, square that divided by expected for the first one. Add the second one. On test, I'm not going to ask you to find the answer by hand, because you're not going to have enough time. But all of you know how to subtract, how to divide, and use this power anyway. The last one. And also here we have this part number 1 and number 2. I'm going to work on that part here on fourth page, because I have exactly the same thing here on this page. Those are requirements that we should have before starting to test. So chi-square test for independence. To test association between two variables, we have to use these steps. Again, we're going to have 6 steps. So first, we should have these 2 requirements before starting these 6 steps. So as always, first, verify your requirements. Number 1, all expected frequencies or all expected counts. So this one is frequencies or counts are greater than or equal to 1. So we should have that one. Number 2, no more than 20% of expected counts are less than 5. So we should have these 2 requirements. I'm going to explain these 2 better when we're trying to find the answers on the next page. After having these 2 requirements, now be ready to start with step 1. For step 1, as always, you should know what null and alternative is. This part is easy to write. We all know that for null, we always have equal in between of proportions. But here, instead of writing all those, first, we can write this way. But another example that I have here on page number 6, I will write the proportion that are equal to. So let's see what we have here. So the row column the row and column variables are independent. For this part, we always have are independent for null, and for alternative, are dependent. We can write are dependent, or we can write are not. Are not independent. Step 2, we have to find alpha as always to be able to compare with P. I combined step 3 and 4. Why? Because if we try to use TI-8384 at the same time, we are able to find chi-square and also p-value. So we can find both of these here and using these steps. Step 5, after finding p-value, we can compare that with alpha, and finally state conclusion. What we have here, we have 2 rows again. We have men, women, and we have 2 columns as pro-life, pro-choice. And here they were as male and female Americans, whether they were pro-life or pro-choice. When it comes to abortion issues, results are here. Part A, test whether an individual's opinion regarding abortion is independent of gender, and our alpha is 10%. So alpha is given that's 10%. And here these numbers, 196, 239, 199, 249, these are observed. For this part, first I'll try to find expected counts by hand. So first step, adding these two to find total for the first row is 395. These two, that is equal to 488. Now adding these two, here is 435. And here we have 448. And our sample size, we can add 395 plus 488 to find total, or 435 plus 448. Again, you're going to have same answer, 883. This is what we have for sample size. Okay, trying this one again. Okay, now finding expected count. So the part that is given on top, this one is observed. So these numbers are for observed. Now here we're trying to find expected. For example, this part here is women, and here is pro-choice. For women, we have our sum is 440. Okay, it's 488. 488, and here for pro-choice we have 448. So adding these two, multiplying these two, 448 multiplied by 488 divided by what is total is 883. So this is expected count for this part rounded to 2 decimal place. One more. For example, this part here is women pro-life, and pro-life is sum was this one 435. Can run it here 435 multiplied by, for women sum was 488 divided by what is total 883. Running to 2 again, 240.41. Now here men pro-life, so men is 395 multiplied by 435 divided by 883. Rounding, here is 194.59. Men pro-choice, men is 395, pro-choice is 448 divided by 883. Men pro-choice, men is 395 multiplied by pro-choice is 448 divided by 883. So this one is men pro-life. Men is 395 multiplied by pro-life. Sum is 435 divided by total. Our requirements, the first one was that we should have all these greater than equal to 1. So these are our requirements. The first one, all expected frequency or expected counts are greater than or equal to 1. So all of these are greater than 1. So I'm going to write all expected frequencies are greater than or equal to 1. Number 2, here, no more than 20% of expected frequency are less than 5. We may have our expected frequencies less than 5 because here, on number 1, it says that we may have this equal to 1, right? So none of these are less than 5. You only need to write none are less than 5. That's it. So we have the first and second. Step 1, null and alternative. Our null. Here, I'll just write the row and column. Variables are independent. And here for alternative, are dependent or are not independent. are dependent or are not. Independent. Alpha is given as 10%. Step 3 and 4, here we have to find chi-square. So this one is chi-square test. And we have to find, we're gonna find p-value at the same time. Okay, now I'm trying to find the answer for chi-square and p-value using Statcrunch first. And then after that, I'll try to find the answer by TI-8384. So here using statcrunch.com. So this one is pro-life, pro-choice. Here you can find this data, this table in our group, pro-life, pro-choice. Now here we have stat tables, contingency with summary. So these are steps to find chi-square and p-value, stat tables, contingency with summary. Here, based on what is given here for observed values on this table, we have two columns. It's pro-life, pro-choice. So select columns. I have these two on the right side. And our row is gender. That part is optional. Now here in display, I'm going to choose, let's try these. Percent of total, expected count, contribution to chi-square. And this probably, we only need expected count, but let's try to find all these three. Hypothesis test is chi-square test for independence. So the first one. And we don't need the support, confidence intervals. Here, confidence level, based on what alpha is. Alpha was 10%, so finding confidence level is 1 minus alpha is 90%. Because alpha was 10%. So this one is 90%. Compute. So the first one, and this is for percent of total. These numbers 22.2. This is 22.54. What you need in this case, expected count, it's second row. Is this one? For the first one is 194.59, which is exactly the same as what they have here by hand. For women and pro-life is 240.41. Again, same thing. For men and pro-choice is 200.41. Again, same. For women pro-choice is 247.59. So again, it's same answer. And here at the end, degree of freedom is equal to 1. So in this case, the degree of freedom. We have how many rows we have? We have 2 minus 1. Column, again, we have 2. Number of columns is 2. So minus 1 is 1 times 1 is 1. Because we have 2 columns and 2 rows. And this one, the value, this 0.0363, this is chi-square. Rounding to 3, the answer is 0.036. And our p-value is 0.8489. So chi-square, I rounded, and the answer is 0.036. And p-value, I'm going to round to 3 again. So it's 0.849. Now that we have our p-value, so that is step 4. Step 5, compare p-value with alpha, p-value 0.849. 849. Is this one less than 10%? So our answer is no, do not reject. No. There is not sufficient evidence to conclude that. Here we have gender and opinion and abortion are associated. Are associated or are dependent. So there is not sufficient evidence to conclude that. Because we didn't reject no. This was using Statcrunch. Now let's use TI-8384. So it's second x to the power -1. This is matrix. See, that is matrix. Now here on top we have names, math, edit. So we have to use edit. Enter. Now what we have on this page is, this is matrix A. This is 1 in 1. So this is one row and one column. But here what is given on this part, how many rows we have was 2 and column was 2. So it's 2 in 2. Changing that one to 2. And here 2. See, now I have all these 4. And enter these numbers that are given: 196, 239, 199, 249. So 196 is the first one. Now here the second is 199. Here for women pro-life is 239. And here 249. Okay, so this is our matrix. So what we did, the first step, using matrix. Number 2, we entered our row and column. Number 3, entered the numbers that were given. Press second, quit. Step 1, 2, 3. Okay. Enter the cell entries for the observed matrix. We already did that part. And press second, quit. Repeat steps 1, 2, 3 for expected values. Okay, I'm not going to do that part, but enter the expected frequencies in matrix B. We don't need that one. I'll explain why. Then step 4, press that highlight test menu and select chi-square. So after this one, I'm going to jump to this part, step number 4. So stat test finding chi-square. Okay, so this one is chi-square test. Here we have our observed was matrix A, expected B. We didn't try to enter what we have for expected here, so that's fine. Now here calculate. Here we have chi-square is 0.0236. It's same as what we had on Statcrunch. Our P is 0.849 after rounding, and degree of freedom is 1. Now if we try, so these are our answers, same answers. But if you're trying to find expected, the part that we didn't enter here, asking step number 3, we didn't do that part. But if we try to use matrix again, second x negative 1. Here, edit. See, I only did number 1, matrix A, 2 times 2. After finding chi-square, automatically we're gonna see number 2, matrix B, is again 2 times 2. And if I use that one in the enter, you'll be able to see all these expected cons without even trying to find them. On test, when you had this kind of questions, first step is find all these answers all together. Okay, then using all these answers, start with requirements part, because you need to know what is your expected cons to be able to work on requirements. And then here test, writing all these, and you already have the answers. You only need to again use this one. Okay, use this one stat test. So on test, you only need to write all these on piece of paper. See, these are our answers. So chi-square over p, and finally compare with alpha, conclusion. That's it. Now part B, construct a conditional distribution of proportion opinion by gender and draw a bar graph. We already have this bar graph on test for this section 12.2. I will not ask you to draw a bar graph. You already know how to draw. Does this evidence support your conclusion in part A? So this one's asking to construct a conditional distribution. I'm going to draw this box. Okay, before that, let me explain what we're gonna do. We're gonna create a relative frequency chart and bar graph. So again, we already have bar graph here. Okay, now I'm going, since we trying to find relative frequency, we have to use these observed cons. So observed values. For the first one, we have mean pro-life is 196. So use that one. And divided by what is total for men is 395. Here for men pro-choice. For pro-choice, here we have 199 divided by total for men. Now women, here is 239 and here is 249 divided by, both of these divided by 488. Okay, I'm running to 3 decimal place. This is 0.496. This one is 0.490. Here is 0.504. Here is 0.510. So if in case on Pearson was asking to draw this one, for example, for men pro-life, so here we have pro-life and pro-choice. This one is pro-life for both men and women, and pro-choice is this one, this color. So for pro-life, for men, we have 0.496 is this one. So this point is 0.496. And for women, we have 0.49. Okay, it's very close. And does the evidence support your conclusion in part A? So what we had in part A here, our conclusion was that we're not going to reject null. So these two row and column are independent. As you can see here, if we compare these two, men and women, the answers are very close. For men, we have for pro-life is 0.496, and for women is 0.490. So these are very close numbers. Same thing for pro-choice. So what we have on this table on a related pregnancy, we can see that the percentages are very close. And the bar graph suggests that the proportion of individuals, so it's same as writing conclusion. Proportion of individuals' opinion regarding a portion doesn't differ by gender. And this one supports what we had in conclusion part A. Here again, we have chi-square. So again, exactly same thing, but the only difference between this one and what we had in the first example here on top is that here instead of 2 variables, we have more than 2, but we have exactly same thing. So for null, again, our variables are independent, and alternative are not independent or are dependent. But here, the way that we're writing, it's same as what we already had in all those sections. For null, we always have equal to, between of proportions, and for alternative, at least one of those population proportion is different from the other one. What this means, you may have something like this. P1 equal to P2. This one is not equal to P3. This is equal to P4. Is not equal to P5. You may have something like that. But instead of writing that way, we have this one, at least one is not equal to. Now in this part, we have 3 columns, 2 rows. So it's not 2 in 2, it's 2 in 3. Example number 3, in recent survey conducted by the by this center, the people in the press, random sample of adults. So here our sample size is, okay, it doesn't say, okay, random sample of adults 18 years of age or older living in United States was asked their reaction to the word socialism. So here we have 3 groups. Here we have Democrat, Independent, and Republican. And but the answer was if that was positive or negative. Part A, does the evidence suggest a different proportion of individuals within each political, and okay, if they react positively to the word socialism, use alpha equal to 5%. So for positive, we had 220, 144, and 62 for each one of these 3 groups. Okay, again, we have to find sum first, but we don't need to because we're going to use our TI-8384. So on test, don't try to find the answer by hand because you don't have enough time on test date, but instead use TI-8384. So here's some. We have 426, and here is 1040. Table total is 1466. And I try to find the answers for by hand for expected, and these are what I have. It's 145. Here 354. This one here was 160.99. 393. And here we got 120.01. Finally, this one was 292.99. Okay, so these were by hand. And here we have our matrix is 2 in 3. For this one, I'm going to use TI-8384, not Statcrunch, because on test you're not able to use Statcrunch. Okay, so second, x to the power -1. Edit. Enter. Here we have 2 rows and we have 3 columns, so change that one to 3. We have to clear these. Fine, so enter all these numbers. For observe is 220, 410, and finally we have 351. Okay, now that we entered all these observed, we are ready to find chi-square and p-value. So after that part, I'm not going to enter expected count, but right after entering observed, use stat test chi-square test. Enter. You don't need to enter anything on this part. So enter, enter, enter. Here we have so our chi-square, I'm going to round to 3, is 96.733. And our p-value here is 9.876996 multiplied by 10 to the power -22. So running to 4 decimal places, the answer for p-value is 0 because of having that power is -22. And degree of freedom is 2 because we have 2 and 3 column. Okay, here, writing this one here, degree of freedom is equal to 2 minus 1 multiplied by 3 minus 1. So it's 1 times 2, it's 2. Here, requirements. The first one was that all expected frequency or all expected count are all of these greater than or equal to 1, expected count or frequencies are greater than or equal to 1. And the second one, do we have any less than 5? So none are less than 5. So we have these 2 requirements. Now step 1, null alternative. For null, I'm going to write, since here we have 3 columns, so I have population proportion for the first group. I'm going to use D for Democrat. That is equal to population proportion for second group. Independent is I, equal to population proportion for Republican, it's R. So here we have 3, and for alternative, I will just write at least 1 is different. So at least 1 proportion is different. Here alpha is given as 5%. Step 3 and 4, these are combined. And our answer was chi-square. So chi-square is 96.733. And our p-value is 9.876996. So I didn't round here. Multiplied by 10 to the power -22. So running this one is very small number. That's why I'm writing 0 positive. Depending on what it's asking, if it was asking to run to 4 decimal places, you're going to write this way. Step 5, compare this p-value alpha or p-value point. Again, since I didn't ask to run to 4 decimal places, I'm going to use this 0 positive because this is a very small number, and compare that one with 5%. So this is less than, and we have to reject. So rejecting null. And finally, conclusion. Since we rejected, now here we have there is. To conclude, so we're going to have different proportion. With an age, political, so they reacted positive to the word socialism. So we rejected null, meaning that we're gonna use alternative instead, and for alternative we have at least one proportion is different. Here again, the support B is exactly the same as what we did on this example finding relative frequency. So I'm going to draw that word. And that's what we have. Democrat, we have independent, and we have Republican. Here the answer positive. Here is negative. I'm using what we have for observed. Here we have 220. Here is 144. Here is 62. Okay, I can see. Now this one for negative, we have 279. Here is 410. And here is 351. Since we're trying to find relative frequency, we have to divide by what is sum for first column. Total for Democrat was 499. So I divide by that one. I'm dividing what is total for each one of these groups. So here I have 0.441. Here is 0.559. Here is 0.260. Here is 0.740, 0.150, and finally 0.850. Well, I don't have part C, but I want to add this one. Okay, so this is same as what we did on the example number 2. So I'm adding this one, write a summary. Okay, the reaction. To this word. So based on what our conclusion was, that we rejected null, and what I have here in this box, so independents and Republicans, these are they are far more likely to react negatively to this word. The word socialism than what we had for Democrat. Because here, if we compare these numbers, see for independent and Republican, we have 850, and here 0.850 and 0.740. But for Democrat, we have 0.559. This 0.74 and 0.85 are closer, but here this 0.56, if I round it, 0.56, that is less than what they have for independent and Republican. But it's important to But if I compare the answers for Democrat, the answer that they had for positive and negative, again, those that have negative, that number 0.56 is greater than 0.44. So they had a negative reaction. So the word socialism has a negative connotation among all groups. So this is what our conclusion was based on this table.